So I hope now I am audible, and we will start now discussion. So today we will start with the PDA, and as we have discussed already, deterministic PDA. So today I will start with non-deterministic PDA, and some example of non-deterministic PDA also we have taken. And now I will define not NPDA, or you can say non-deterministic PDA, as in mathematical definition. So like PDA, NPDA is also a 7-tuple machine, and PDA is also 7-tuple machine, and tuples are exactly same, capital Q, and then sigma, then gamma, then delta, then Q0, then Z0, and F. So now in case of all tuples are same, like Q, capital Q is finite set of all possible states of the PDA, then sigma is finite set of input symbols of PDA, then gamma is finite set of stack symbol, and transition function delta is transition function, Q0 is start initial state of PDA, and Z0 initial stack symbol, and F is a set of all final states of PDA. Now in case of DPDA, the transition function is, as we have discussed, Q cross sigma cross gamma. It gives us Q cross gamma, screen closure of gamma. That means here we are considering current state of the PDA, then we are reading one symbol that is coming from input symbol, and then we are also taking top of the stack as consideration. So this is coming from gamma, and for this combination we are giving one next state and current of whatever elements of stack we are representing with clean closure of gamma. Now here, as we have seen in DPDA and NPDA both, we are taking epsilon also, we are reading epsilon also. In some cases we are reading epsilon also when string ends, so we read epsilon. So here in both the cases you need to include epsilon as one of the proper one of the input. Now this is proper transition function of PDA. So in case of DPDA, as only one possible next state is there, so this would be the transition function. And in case of NPDA, which we are going to discuss now, in case of NPDA, delta would be Q cross sigma union epsilon, as we are also using epsilon here, cross gamma, gives power set of 2 to the power Q cross sigma. And here power set of means there may be more than one next state for this NPDA. So this is the difference between transition function of DPDA, deterministic PDA, and NPDA, non-deterministic PDA. So I hope it would be clear. And now If you have any question, you can write to me in comments. And now we will start. As I have already taken some example of NPDA, so now we will start with another topic, which is conversion of CFG into PDA and PDA into CFG. So these two conversions we need to discuss now. So now we will discuss conversion of CFG, conversion of context-free grammar to PDA. To PDA. Now, as we have discussed, friend, like for a CFG, the mathematical model that we use to implement CFG in machine, this is PDA. So every CFG can be converted into equivalent PDA, and every PDA can be converted into equivalent CFG. So now you can see we have two types of PDA here. PDA, we have discussed PDA acceptance with in two ways. So PDA, some PDA, we can create PDA for acceptance by empty stack, accept by empty stack, or by another PDA is there. Another way of designing PDA is acceptance by final state. So these are the two ways by which we can accept a string in through PDA. And here, if we are converting CFG into PDA, so we will use this kind of PDA, which is accepting strings by using empty stack. Oh, sorry, this is empty stack. So acceptance by empty stack in PDA, that we will use while converting CFG into PDA. So now I will start with conversion. I will take some grammar. I will tell you some rules first, and then I will take some grammar as example, and we will convert it into PDA. Now, before starting conversion, we must know, like CFG are maybe of two different types. And as I told you, as we have discussed already, the normal forms of CFG as uh, uh, CNF and GNF. So for PDA implementation, GNF is better approach to use. So GNF is most commonly used for PDA implementation of CFG. So in case of CFG, there again we can convert CFG first into GNF, or we can directly convert CFG into PDA. So two categories are there. If your CFG is in GNF, or CFG is not in GNF. So two type of grammars you can have. Those are in already in GNF or not in GNF. So for both the category, we will discuss and we will take one example for both type, and I will tell you how to convert particular type of CFG into PDA. So now here we are considering first not in GNF. That means any grammar which is not in GNF, then how we will convert that particular grammar into PDA, that we will discuss. So now you can see, friends, like in grammar, in case of grammar, we have four tuples: V, T, P, and S. And in case of PDA, we have seven tuples. We have seven tuples. So like PDA would be Q, then sigma, then gamma, then delta, then Q0, then Z0, and then final state. So all these tuples are for PDA. Now, as we are using acceptance by final empty stack, acceptance by empty stack, so there will not be any final state. So this would be for converting CFG into PDA. Tuples of PDA would be like Q, then sigma, then tau, this gamma, and then delta, then Q0. In place of Q0, we will use only one state, Q, only one state. And this capital Q will have only one state here, which is Q. So it would be initial and final, initial state only. And then Z0, in place of Z0, we will use star symbol of grammar, and final state would be 5. Final set of final state would be 5, because there is no final state, as we are accepting all strings through empty stack. Now this gamma is here in case of grammar not in GNF, so gamma will be union of V and T, both variable and terminal of the grammar, So gamma would be union of variable and terminal, and the sigma would be mapped to T, terminals of the grammar. Then delta we will write, and Q is their initial state, and S is their top initial stack symbol. And as I told you, we are accepting strings by empty stack, so set of final state would be 5 in this case. Now I will take one example grammar which is not in GNF, and I will tell you how to convert that particular such grammar into PDA. So I will take one grammar here. I can have A gives 0, A 1, and A gives 0, 1. So now suppose this particular grammar is given to us. Now how to convert it into PDA? So now we will write all the transition of PDA equivalent to this grammar. So now how to write all these transitions? So as we are using only one state there, so we will use this state only, Q. Always the current state of PDA would be Q, and if top of the stack is any variable, as we can see here in a stack, we can push variable or terminal both. So if on the top of the stack, if variable is there, we will not use or we will not read any symbol of the string. And as we are not using any symbol of the string, so input symbol would be empty in this case. Input symbol would be empty in this case. And whatever initial state is there, so sorry, we are having a here. So a is the only variable in this grammar. So we will use this like this. Now, this left hand side variable is current stack top. This left hand side variable is current stack top here. Now, we have seen the current state, we have seen the input that we are reading, and we have seen the current stack top. Now, this combination will give us the next state would be again Q. As I have told you, there is only one state. So it will be again Q, and the stack, the symbols into the stack we are pushing would be the right hand side of the stack, production, right hand side of production. So you can see this complete string we will push into the stack. And we have seen already the PDA, when we are writing this string in the transition, that means current, we also include current stack top. And here I have not included current stack top, means before inserting it, this particular string, we will remove current stack top from the stack. So this is why I have not pushed this put a here in the right hand side. So now how I have written this particular transition. So my current state is Q. If variable is there, so see here variable is there in the left hand side. So left hand side variable is considered as current stack top. And if current stack top is variable, then we will not read any symbol from the stack, sorry, from the input. So it means it is epsilon. And for this combination, we will stay in Q state, and we will push the right hand side of production into the stack. Now, considering this, we have written this rule. Now, I will write transition for this particular production. So now current state is Q, and left hand side variable is current stack top. So as stack top is variable, so I will not read any symbol from the input, and I will read epsilon in this case. And now again the new state would be Q only, and the next we will input pushed into the stack as 0, 1, the right hand side of production. So based on these two productions, we have written these two transitions for PDA. Now you can see in both the transition, left hand side is same. Left hand side is same. So on this combination, either we can use this or we can use this. So this means for single combination, there are two next state. That means it is NPDA. So while you convert CFG into PDA, so mostly you will get NPDA as written. Now there are some more transition to be written, like how we are going to write these. Now all input symbols, all terminals of the grammar will be used there, as very simple transition is there, as current state is always Q, and this is 0, so 0, and 0 would be stack top, and then we will stay in Q stack itself, and we will pop the element from the stack, and for all input symbols we will write the production like this. So again I am writing, there are only two terminals, 0 and 1. So for both the terminals I will write the same rule. So like So now these four transitions I have written for PDA equivalent to this grammar. So I hope it would be very much clear. Now I will take one example string and I will show you how this particular PDA is accepting all strings from this grammar. All strings from this grammar. So now I am taking one example string here, AA, sorry, 0, 0, 0, 1, 1, 1. This string I am taking. Now, this is the string. Now, initial stack symbol, as I told you, would be the star symbol of the grammar. Initial stack symbol would be the star symbol of the grammar. So I can take A here as A is the only variable in the grammar. So now you can see we have inserted A into the stack. Now we will start reading this symbol, right? Now you can see we are stack top is variable. Stack top is variable. So in this case, we will not read any symbol from the stack. Sorry, any symbol from the input. So as the pointer is here, but we will not use this input and we will consider we are reading epsilon here. So in case of epsilon, we are reading current stack top is A, then and we are in Q. So we will stay in Q and we will insert 0A1 into the stack. So as you can, as I have told you already, that we are not repeating the current stack top in right hand side. So that means before inserting this query complete string, we need to remove the current stack top. So I am removing it. Now I am adding three different variable here as 0A1. So this complete string I have pushed into the stack. Now current stack top is 0. Current stack top is 0. So now you can see we have one transition where current stack top is 0. So now we can use this particular input here. So now we are reading 0 and current stack top is 0. So what we need to do here, we need to pop element from the stack. So I will pop this element 0 from the stack and now I can move this pointer to next input. Now again stack top is A. Stack top is A. This is variable again. So in case of variable on the top of the stack, we will not read any symbol from the input. So now again we are using having A on the top of the stack and we are reading epsilon from the input and we are in state Q. So now we can use this transition or this transition. So we will use again this transition and I will see I will push complete string, complete right hand side string of right hand side here. So before inserting this string into the stack, we will remove current stack top. So this would be like 1, A and 0. Now 0 is on the top. So now I can use this transition. Now we are having 0 on the top and we are reading 0. So this combination is we are getting. So according to this combination, what we can do, we can remove top from the stack. So we will remove this. And as we are removing this top from the stack, so we can move our input pointer to next symbol. Now we have A on the top. Now we have A on the top. Now you can see we have A again on the top. So in case we are having variables on the top, we will not use input symbol. We will read epsilon only. So in this case, you have two transition for this combination. both the time we use first transition. We will again use the first transition ideally, but as I can see here, we need to generate 3 zeros only. So now this time I can use this transition. So now on we are on Q, we are reading epsilon, and stack top is A. So now this time we will use this transition and we will stay on Q, but we will push 0 1 onto the stack. So I can push 0 and 1. So before inserting 0 1 into the stack, we will remove current stack top. Now we are having 0 on the top of stack. So we have one production where 0 is on the top of the stack. So we are on Q, we are on state Q, we are reading 0, and we are having stack top as 0. So for this combination, we can remove top of the stack from the stack. So now, oh sorry, now I can remove this 0 from the stack, and as I am removing this symbol from the stack, so I can now move my input pointer to next symbol. Now we are having again 1 on the top of the stack, which is again terminal. So we can use this particular combination. We are on Q, we are reading 1, and we stack top is 1. So what we can do, we can remove this from the stack. So I will remove it, and as I'm removing, I can move my pointer to this. Now again we are having the same combination. 1 is on the top, we are reading 1, and we are on Q. So again we can use the same transition here. We can again remove the symbol from the stack, and we can move the pointer to here. Now again we are on getting same transition, sorry, same combination. We are on Q, we are reading 1, and we are 1 is the stack top. So in this case, we can again remove this symbol from the stack. As this stack is empty, so that means this particular string is accepted by the PDA. So I hope it is very much clear to all of you. And if you have any doubt, kindly write me in comments. So now we have taken one example where your grammar was not in GNF, and we have converted this grammar into equivalent PDA. Now we will take one example where grammar is already in GNF, and then we will again convert it into PDA. So now we can see here another grammar. Now we will consider this case. So where CFG is already in GNF. Again, we will have same kind of PDA here. Capital Q. Capital Q is having only one state Q. and input symbol would be mapped to terminals. Then gamma here gamma will have only variables. In case your grammar is not in GNF, sorry. So gamma was storing both variable and terminal. But in this case, when your grammar is in GNF, gamma will store only variables. Then transition we will write, and then q0 in place of q0 only state q will be there. Then in place of z0 again star symbol of grammar will be there, and then final state set of final state again would be phi. So now I will take one example where this particular combination is there. So now I will take one example. A gives 0A 1B B, and B gives 0 and 1. B gives 0 and 1. So now you can see, friend, all the productions are in GNF. All the productions are in GNF. So now I will take this, I will convert this particular grammar into PDA, and I will show you how to convert it. So now again we can see, as now we have grammar which is already in GNF, so there would be some different way to convert it into PDA. So now again, as we have taken only one state in this PDA, so we will be in state Q. Then left hand side variable would be current stack top, and right hand side terminal would be the current input symbol. So for this particular transit production, I will write like this. So 0 and current stack top is A, and then it will gives us Q0, sorry, Q and A. So this is the only production, and this is how we can write production. So that means left hand side variable would be considered as current stack top, right hand side terminal would be considered as current input symbol that you are reading, and whatever list of variable is there in the right hand side, this would be the next string of stack. So we have written this particular transition using these rules. Now again we have Q as current state. Now this time we have one input symbol, and now A is on the top of the stack. So now we can be in Q, and we can now insert B into the stack. Now this is, again you can say Q. Now there are again productions where we are generating only single terminal. So we can use current state as Q, current input symbol as 0, and now you can see nothing is there in the right hand side, but current stack top we will consider as left hand side variable B, and this will be written as Q, current next state as Q, and as there is nothing here, so we can use epsilon here. And here epsilon means we will pop element from the stack. Now again, for this particular production, we can write Q, then current input 1 and stack top is B, then we can write it Q and epsilon. Q and epsilon. So now this is how we can convert that particular grammar into GNF. Sorry, into PDA. Now I will take one example string from this language and I will show you how it is accepted by the PDA. This PDA. So now I will take one example string here as 0, then 1, 1, 1, 0, 1, 1, 1. So this is valid string for this grammar. So now we will see how it is accepted by PDA. So now, as I told you, star symbol would be the current initial stack symbol. So here we have A as star symbol. So I can insert A into the stack. Now, current first 0 we will read here. We will start reading string from left to right. So we are reading 0. Current stack top is A and we are in Q. So this combination we are getting. So now what we will do, we will stay in Q. We will remove current stack top and we will put this string into the stack. So current stack top is A. So we will remove it. And then we will put right hand side string of production in the stack. So now we have pushed A again into the stack. Now as we have removed some variable, some element from the stack, so we will consider this. Now we will move shift the input pointer to the next symbol. Now we have 1A as input, A on the top of the input, stack, and we are in Q. So in this case, we will stay in Q and we will push BB into the stack. So before inserting BB into the stack, we need to remove it and we need to push BB like this. Now you can see we will move to this pointer again. Sorry. We will move now on Q0 on Q. If we are reading 1 and stack top is B, so we will pop element from the stack. So we will remove this B from the stack. And as we have removed something, so we can again move the pointer to here. Now, again the same combination. We are in Q, we are reading 1 and the stack top is B. So again we can use the same rule and we can remove this B from the stack. And in this case, as stack is empty, so this means this string is accepted by this PDA. So as I told you, we are implementing this PDA by acceptance by empty stack. So this is how you can convert any CFG which is in GNF or which is not in GNF into PDA. So this is the example we have taken. I hope it would be very much clear. Now I will complete this class here. In next class, we will discuss the reverse conversion, CFG to PDA to CFG. We will in next lecture we will discuss PDA to CFG conversion. So I hope it would be very much clear. Thank you. Thank you so much.